it's Miss Curry. I'm really excited to see you today, and I'm looking forward to our lesson. We get to solve a math story. We'll also take a look at how other students solve the same story. Let's get started. Let's read together. Colby is reading a book that is 14 pages long. She just finished reading 8 pages. How many more pages does she have left to read? This is a great story problem. I love reading. Do you love reading? What's your favorite book? Oh, I love that book. Let's read the first sentence again. Colby is reading a book that is 14 pages long. Is 14 the total or a part? It's the total. Very good. Can you think of how you might represent this part of the story in a drawing? Think about it first. Okay, now tell me. Next, it says, she just finished reading 8 pages. Is 8 a part of the total pages? It sure is. Are you ready to solve this problem? Push pause and draw a picture and write a number sentence to find out how many more pages she has left to read. Push pause now. Oh, hi, welcome back. While you were working, I collected up some student work samples for us to take a look at together. Let's start with student A's work. Take a moment to examine the work. Can you tell me what you think student A was thinking as they solved the problem? This student drew 14 fingers to represent the total. They saw the 14 as 10 and 4 more. So they took 8 from the 10 and got 2. Then they just needed to add it to the other 4 fingers and they got 6. So this student knew that 14 minus 8 equals 6. Do you know what this strategy is called? It's called the take from 10 strategy because they took from the group of 10 or the 10 fingers. Can you think of another good way to make a math drawing for the take from 10 strategy? Yes, a 5-group row is a great math drawing to show take from 10. Let's look at student B's work. Take a moment to examine it and think about what the student might have been thinking. How did student B solve the problem? This student drew a picture, but it's a little hard to see because the shapes are not organized. They drew 14 circles and took away 8, and then circled the leftovers, and then they probably counted all of them like this: 1, 2, 3, 4, 5, 6. Is this the correct answer? Yes, it is. We'll label this strategy make a drawing. Next, let's look at student C's work. Take a moment to examine it. This answer is 14. Is that correct? Is the work correct? Parts of it are correct, but not all of it. But there is some good thinking here. Let's start with what the student did correctly. This student broke apart 14 into 10 and 4. That is correct. But look at the number sentence. 4 minus 8 equals 4. This is not correct. 4 minus 8 means we start with 4 and we take away 8. Well, let's see what happens when we take away 8. Here's taking away 1 finger, take away 2 fingers, take away 3 fingers, Take away 4 fingers. Uh-oh, I don't have 8 fingers to take away. That means that 4 minus 8 would be less than 0. And we don't know how to do that yet. It also says that the answer here is 14. But that doesn't make sense. We started with 14 and took away 8. So our answer needs to be 8 less than 14. What would you say to student C to help them fix their mistake? Take a moment to think about it. How can they fix their mistake? Yes, I agree. And I would tell her always to check what number you're taking away. In this problem, you have to take away 8. So you need to subtract 8 from the 10. This student's work was trying to do the take from 10 strategy. So that's how I'll label it. How did student D solve the problem? Take a moment first to examine the work. Okay, tell me. Student D counted on from 8, like this: 8, 9, 10, 11, 12, 13, 14. Then they counted how many counts that took to get from 8 to 14. Do you know the name of this strategy? This strategy is counting on. Our last student work sample comes from student E. Take a moment to try and understand what they were thinking. What strategy did student E use? Some of you said make 10, and some of you said counting on. Well, I would argue that they're both correct because they're counting on from 8 in a chunk to get to 10, and then they're counting on in a chunk to get to 14. So let's call this get to 10. Let's look at all of this wonderful student work again. Except for student C's work, do all of these show ways to solve the problem correctly? They do. And that is why I love math so much, because our brains think about the solution pathway all a little differently. Look at the different strategies. Does there seem to be some strategies that are more efficient than others? Remember that efficient means that you make a problem easier and quicker to solve. And now it's time to show what you know. Your must do problems are 1 and 2. Do your very best thinking for 10 minutes, and if there's time left over, try number 4. As